Hello, my name is Ife Martins, and if that sounds too complex, you can call me Alagba Benjamin. I believe that should be simpler for you. Well, welcome to Kini Big Deal, and this is an introduction to indices and exponents. If you don't know what indices and exponents are, I'm afraid you may have to look for excuses in your mathematical endeavors or your mathematical attempt throughout. I don't know, maybe throughout your mathematical lifetime or anything. But my point is, judging from my own personal experience, SS1, I ran away from this topic feeling like a bad guy, you know. And later on, it's really dealt with me because every other thing that I was taught built on the simple concept of indices. And if you miss the basics, what can you do with the later ones? You'll just be, messing around and all those things. So my plan here now is to give you a nice introduction to indices and exponents so that when you see all these nonsense, this raised to power that equals x, blah blah blah, you know exactly what they're looking for. Take for example Mr. Buleshowo here. Welcome you to his yellow house, okay, which is the base. Welcoming you to yellow house raised to power red house. Now, from the picture here, you can already see that the base is the big number and the power is the small number, just like the red house we have over there. So, without delaying you further, let's go to the real concepts. Now, what are exponents? Don't worry, I'll be using exponents and indices together. You can call them exponents, okay? If you are not angry about my writing, it doesn't even matter. I might not the one teaching you. Exponents, you can also call them indices, okay? Now, what do they mean? Generally, exponents and indices, they are like any other operation, the way you have plus. Once you see plus and someone gives you 2 plus 2, you already know they want you to what? Add 2 to 2, okay? Sorry about that. 2 to 2, which gives you 4. If you have a sign like minus, it means they want you to subtract something from other. So if you have 4 minus 2, that means they want you to, let me embarrass you a bit. 1, 2, 3, 4 minus 1, 2. So you say 1, 2, take it away. What is remaining? 1, 2. Answer equal to 1, 2, or 2. Okay, it's not that simple. I'm just kidding. But really, the whole idea is that the same way you have something like multiplication that says 2 times 5. If someone tells you to multiply 2 by 5, what they're basically asking you to do is to do a repeated addition. So it means 2 plus 2 plus 2 plus 2 plus 2. Now let's see how many 2's we have. This is 1, 2, 3, 4, 5. Okay, let's pretend that you don't even know how to multiply. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2, 8. 8 plus 2 equals 10. So generally, you can say multiplication is as a result of repeated addition. So once you understand that kind of concept, getting indices becomes extremely easy for you because the whole idea of indices is repeated multiplication. If that sounds like big English, indices means multiplying a number a certain number of times by the same number itself. Calm down. I know your English is not that good. Okay. So this is what I mean. What I mean is if someone tells you to do 5 raised to power 3, it means multiply whatever is here, okay, which is your base. Remember Mr. Abuleshowo, which is your base, this number of times. So it means 5 raised to power 3, which you may not see very well again, means 5 multiplied by 5 multiplied by 5. How do you know when to stop? Because this is first 5, second 5, third 5. You get the idea? So you multiply that and you have 5 times 5 is 25. 25 times 5 equals 125. So exponents are actually a mathematical operation that tell us what to do with numbers. They tell us how much we can multiply a number by itself. And you may begin to ask me, okay, what is the usefulness of all these big grammar, big whatever? The whole idea is there are some numbers that it is very unnecessary, or would I say very stressful, to represent in their normal form. Maybe some mathematicians, sorry, are trying to, raise, they are trying to reduce the amount of money spent on ink or paper, or they are just being lazy, like you. Okay, okay, lazy like I was anyway. Don't get offended about that. So the whole idea is that once you have exponential or exponents or powers, it means you're doing a repeated multiplication. So the same way, let's clean this off now. If I tell you to do 2 raised to power 4, it means multiply 2 by itself 4 times. So this is 2 times 2 times 2 times 2. How many times? 1, 2, 3, 4. 2 times 2, 4. 4 times 2, 8. 8 times 2 equal to 16. So 2 raised to power 4 is equal to 16. Okay? Of course, in more sophisticated videos, you have things like 2 to the fourth power. Please, don't be deceived. It's the same thing. 2 raised to power 4. Now, moving on from there, you can now start thinking of things like, what are the peculiar things about indices? Now, the peculiar things is there is this property called commutative property. Yeah, I know the reason why you're on Kini Big Deal is because you don't even like plenty English or plenty Magana, plenty Turinchi, and everything. But the idea is that if you have something like, say, 2 plus 3 equals 5, there's a property that also makes 3 plus 2 equals 5. It's called the commutative property. Okay, it means arrangement doesn't matter. So it always holds true for addition, it holds true for subtraction as well. I beg your pardon. So if you have something like 6 times 3, which is 18, if you also have 3 times 6, what do you have? You also get 18, but that's where it ends. When it comes to exponentials or exponents or indices, you don't have that luxury. You really have to be careful about that, because 2 raised to power 3, which is equal to, like I told you, 2 multiplied by itself 3 times. Oh, I beg your pardon. Okay, 2 multiplied by itself 3 times times 2, which is equal to 2 times 2, 4. 4 times 2, 8. It is different from now converting this one to 3 raised to power 2, which will give you multiplying 3 by itself twice, which will be 3 times 3 equal to 9. You can see the difference. But don't get deceived. Don't think because, oh, well, you came close, they will mark steps. Please don't be deceived by all those kind of ideas. Let's look for a more outrageous example. If you have 3 raised to power 4, it means 3 times 3 times 3 times 3. Okay? It's different from 4 raised to power 3, which is equal to 4 times 4 times 4. Okay? When you're feeling less busy and you think you can handle it, of course, you get the answer yourself, and you discover that this is not equal to the one under it. So now that we have that out of the way, we're already building up a very solid orientation to understand orientation. How can you know the meaning of? Okay, we are building a good foundation or a good starting to learning indices. In the next video, I'm going to show you how to see how to handle common indices, the most common ones. You hear something like something squared, something cubed. We do a little review of what those things mean. Then we go into things you don't like, which is laws of indices. You are maybe lazy like me, you don't have time, or you missed a few classes. You may wonder, what is the idea with law? I mean, we are talking of mathematics, you are telling us law. There are some things we call laws of indices, but for the sake of this class, we won't call them laws of indices. Let's just call them how to handle indices, okay? How to handle indices. So when you have a grasp of how to handle indices, any problem you see, you can know which particular law deals with that problem, then you solve it effectively. This is Alagba Benjamin. I'll see you in the next video. Thank you very much.